Hi, this is Kevin. I'm here for part two of the tutorial for chapter three of the Zell Python book, third edition. And what are we going to be doing here for this second example? Well, let's get started. We're going to create a Python file, right? So, new Python file. And this one is going to be called Quotient Accumulator. So again, we're going to be working with um, division. And here's the Quotient Accumulator. All right. And here are the comments that I have in the top of my pre-baked version. Okay. So we'll be able to go through them. Okay. So the file is called Quotient Accumulator. I I have a link again to the resource on the terms used in division. So again, if you need to refresh your memory, you can go back there. And again, we're going to be doing integer division. And my statement of the intention for the program is accumulate the quotients of a series of 5 integer pairs um, provided by the user. So it's going to be user input again. There are going to be 5 pairs of integers. Okay. And it says use Python integer division. So it's pretty clear what we want to do there. All right. So I created some pseudocode. And here's what it looks like. Okay. And this time I gave it a title, sort of. I said, this is the pseudocode. Okay, but let's take a look and see what we have. So, what is happening here is we're really doing the same work that we were doing in the last problem. We're doing integer division. So we're going to be doing it with the // operator. Okay, and the relationship between the program that I demo here in the tutorial and the program that you're going to do for your assignment is pretty much the same relationship, which is to say, I'm going to be showing and dealing with the quotients, and you're going to be showing and dealing with the remainders. Okay, so it's a real parallel activity. Okay, so now the other thing that we're doing here that we weren't doing in the last one is that we're exploring this this new pattern that was introduced in the chapter, the accumulator pattern. And even though the example in the chapter dealt with multiplication, it's more typical in an accumulator pattern, at least in my experience, to be accumulating things through addition. And that's what we're going to be doing here. So we're going to calculate the quotient from each of these pairs, and that's the answer from each pair. And then we're going to accumulate those, and then we're going to print the accumulated sum. So, couple of things. One is that in our main code, it's possible for us to have a loop in our main code. This is especially true if we're doing some kind of input and calculation over and over again. What we're doing here in chapter 3 is that we're learning how to do it a fixed number of times. In a subsequent chapter, we're going to do it a more variable number of times. And there are some tricks to doing that will be pretty obvious when we get there. But here we're going to loop exactly 5 times. So in our main code, we're going to loop exactly 5 times. So the get user input, and the do processing are going to be within the body of the loop. Okay, so we're going to do those as many times as we do the loop. We're going to do those 5 times. The create output is not part of the loop per se. There's I've added some output into the do processing. I didn't originally have it here, but I thought it was easier to test. So in the processing, we're going to do the division, and we're going to print the quotient so you can see it and make sure it's been doing it. And then we're going to add to the accumulator. Okay? And then in the very end, we're going to print the value that's in the accumulator. Now, I have one other thing, okay? Pretty typically, you can fit a problem into input, process, output. But sometimes you have to do a little work in the beginning, okay? And back in the old days when I learned to program, we had a standard name for this. It was called housekeeping. It was like you're going to tidy up your house before you start. And it's kind of an antiquated point of view, I guess, but still the practice is good. The metaphor is kind of old-fashioned, I think. And so, if in fact we're going to be accumulating these quotients in an accumulator, we had better make sure it is set to 0. So we're going to have this housekeeping that's going to happen one time in our main code. And then we're going to have a loop that's going to happen 5 times where we get the user input and then we do the processing. And then we're going to have the create output that's going to happen 1 time. Okay, so let's see what that looks like in real code instead of pseudocode. Alright, so I'm going to skip 2 lines, and I'm going to def main, where our code's going to go. Alright, and while I'm thinking of it, let me go down and just remember to call main to get it to execute. And again, 1 empty line at the end. Typically not 2, just that 1 empty line. Okay. I think what it doesn't like about main is that it's empty, but that's okay. We're going to put stuff in it. So what are we going to do? Well, again, I'm going to bring in my top level of comments in my pseudocode. So I'm going to use the top level of the pseudocode for comments. Do I have to? No, I don't have to. I accidentally clicked and collapsed on the main there. Okay, so let me tab out here. So I've got housekeeping, and I don't really know why that didn't go where I wanted it to. I wanted it to go here. That's where I wanted it to go. And a couple blank lines, and I've got my main loop. I call it the main loop because it's a loop that's in main. Could I just say loop? Yeah, I guess I could just say loop. Okay, that's good. And then inside my main loop, I've got what? I've got 2 things. I've got one get user input. So let's put that up here. Get user input. Sorry. I don't know how I do that, but some people are just talented, I guess. And then the next one is do processing. And again, this is part of the loop. This is part of the body of the loop, which is why I've even indented the comments. Okay. Okay, I find that helpful. All right, now how much of this commenting you're going to do is really up to you. The code that we have here is probably self-explanatory enough that you don't absolutely have to have these high-level comments. Okay? I like them. I think it's a good style. Okay, now this is going to go here. And again, it didn't put it exactly where I wanted it to be. Okay, so this makes it pretty clear that housekeeping is on the top level of the code. Then we've got the main loop. Get user input and do processing are in the body of the loop. And create output, again, is after the loop. Okay. So let's get started. So housekeeping, we said we were going to make sure that we set the accumulator to 0. So let's do that. Okay, I'm going to set the accumulator to 0. And typically, if I'm separating code within a function, okay, and I'm just putting a blank line to improve the readability, I only put one line, okay? The 2 lines go before and after functions and before and after classes. We haven't created any classes yet, but that's that. Okay, and then the main loop, what's that going to look like? Well, we're going to have a for loop. So we said we wanted it to go around 5 times. Okay, and I just want to say I've decided that I'm going to use the index variable for the loop. I'm going to use it in order to print out some helper text. So let me show you that. Show you the printing of the helper text. And now I'll talk about why I did what I did. Okay. So let me come down here and get a blank line. So what I'm going to do is I want to help the user, and so I want them to know kind of where they are in the input process. So I just say now collecting integer pair comma I. So the first time it's going to be 1, 2, 3, 4, 5, because we said I in range 1, 6. Remember that this 6 is, as hard as it is to believe, this is the first one that we don't want. Okay, so if we want a sequence of 1 through 5, 1 is the start, comma, 6 is the one that we don't want. So we want 5, but we don't want 6. So that's going to get us 5 times through with the right numbers. So it's going to say now collecting integer pair 1, then 2, then 3, all the way up to 5. Okay, so let's prompt for these inputs. And I'm going to put them both in at the same time. Okay, so they're going to go here. Okay, and what do they look like? Well, the first one's going to be the dividend. That's the number we're dividing. The second one's going to be the divisor. That's the number we're dividing by. And we're going to do the typical, we're going to have the prompt string, please enter an integer for dividend, please enter an integer for divisor, inside of an input. So that's going to put out the prompt and read in the character string that gets typed. But in both cases, we want ints. Okay, so we're converting them to int. That means we're going to get an integer value or it's going to blow up. Okay, that's pretty straightforward. Now, let's see what the processing is. Okay, let me show you my code for that. Okay, so my code for the processing is this. So the quotient equals or is assigned a dividend integer divide divisor. Okay, we did that in the last one. Now I've got to print. Now, somebody might say, well, Kevin, isn't that really output? And I would say, yeah, it's kind of intermediate output that we're putting out to be polite while we're processing. I mean, so is now collecting integer pair I. So yes, it's an output statement, but no, it's not a part of the create output function. Okay. So then we're going to print a little documentation thing. The quotient is this, so we'll see that. And now we're going to accumulate the quotient. You'll remember there's a shortcut that you can do. I think I've introduced this, but if I haven't, instead of saying accumulator equals, let's show the original. Accumulator equals accumulator plus quotient. If I do this, okay, I can definitely do this, all right, and it's not bad code, but there is a shortcut for these. This is something we do a lot when we're accumulating things, okay, and they came up with a shortcut, and it's called the plus equal. So if you're just adding something like this, you can say accumulator plus equal quotient, and it means the same thing. Okay? Now I've got to say, when I first started in this style of language, which I guess started with C and went through languages like Java and have come into Python, I didn't like this shortcut, and now I prefer it. I think it's kind of easier to read the line. Okay. Okay, and then what's the next thing that we do? Well, that's the loop. Okay. And you'll see I've got the blank lines in the body of the loop. They're kind of helping me say, well, you know, I've got these parts in the loop. Do I have to have blank lines? Would it be wrong to close up those blank line gaps? No, it wouldn't. I just you're entitled to a little typographic drama, and that's what I think this does. So I like that. And then the last thing that we need to do, which is not part of the loop, is to print out the value of the accumulator. So let's do that. And it'd be nice to put that out where it belongs, right there, so it's under the main. So we're going to say the accumulated sum of the quotients is accumulator. All right, so this is it. This is pretty much a one-for-one interpretation of the pseudocode. Maybe I've thrown in two instances of printing lines of output that make it easier for the user to know where the user is and easier for you to test. Okay. And look at the main. It's got a gray squiggly line under it. Now, what's the problem? It wants two blank lines because two blank lines should be surrounding the function main. So 2 in the beginning, 2 in the end. Okay, this looks good. So I'm going to get mean right there where we can see it. And let's do some testing. Okay, so we want to test by clicking in the code editor and saying run Quotient Accumulator. And let's make this a little bit bigger. Now collecting integer pair 1, please enter an integer for the dividend. So I'm going to do all 3 and 2 for now. So 3, 2. So it says the quotient is 1. Now collecting integer pair 2. I'm going to do it again. 3, 2, 3, 2, pair 4, 3, 2, pair 5, 3, 2. And it says the accumulated sum of the quotients is 5. Okay. Now, one of the weird things is when you do the when you divide 3 by 2, the quotient is 1, the remainder is 1. So maybe 3 divided by 2 is not a good test case. So let's run it again. I'm going to go over here, and I'm going to say 8. Let's think about this. Let's say 7 divided by 3. So that's going to be 2, remainder 1. So let's say 7 divided by 3. Let's make this a little bigger. Okay. And so the quotient is 2, and the remainder is going to be 1. Okay, and then 7 divided by 3, and then 7 divided by 3, and this is the fourth one, 7 divided by 3, and then the fifth one, 7 divided by 3, and the sum of the quotients is 10. Yeah, because the quotient was 2 and we had 5 of them, so we got 10. So that looks like it's doing a good job. Okay. I probably want to test that I was able to detect a bad input. So if I ran it again, and instead of 7, I put in 7.0. Well, it's not going to like that, because that has a decimal fraction, even though it's a 0. So that's going to blow up. And if I ran it again and I gave it the typical text, "Hi, Mom," that's going to blow up too. Okay, so I think I've got this appropriately tested. Now let's just look at this to make sure. I'm going to double click on the editor window so we can see the whole thing. Okay, I'm not going to turn in the pseudocode. Okay, the pseudocode was our scratch pad, so we're going to get rid of that. We want 2 blank lines before, 2 blank lines after. Do I have to have these high-level comments? No, I don't. Okay. Do I have to have the blank lines? No, I don't absolutely have to have them. I like, for me, the blank lines are more or even more important than these kind of summary comments, because I'm kind of, in an editorial sense, I'm saying these lines that are together without intervening blank lines, they kind of go together. Okay. Does the interpreter care? No, the interpreter is more concerned about things like indentations. All right, and now that I have that saved, I just want to go back and I want to test it one more time, because I changed the code. I want to run it again. So let's do my 7, 3, 7, 3, 7, 3, 7, 3, pair number 4, 7, 3, 7, 3, that's pair number 5. And the accumulated sum of the quotients is 10. Okay, so that's it for our tutorial example. Your assignment is pretty much a parallel kind of program, where instead of doing the quotient, you're going to be doing the remainder. Okay, see you soon.